Hi everyone, welcome to BHARGAV SUBS. So, we discussed what is the speed of electromagnetic wave while traveling in vacuum and speed of electromagnetic wave while traveling in a dielectric medium or non-conducting medium. Now, the electromagnetic wave traveling with a velocity and also with some intensity. Okay, electromagnetic wave has some intensity. So, intensity means energy density it will have. So, average energy will have. So, intensity is nothing but traveling with some energy per unit area, like how much energy was traveling per unit area per unit time. Okay, so intensity is nothing but how much energy is traveling per unit area per unit time. This is intensity. Okay, every wave has some energy, right? So average energy per unit area one unit area, like 1 unit per second, per 1 second per 1 unit area. So how much energy is transferring, that is known as intensity, right? So it was traveling through certain area. We have to consider initially some area. So in that we are projected that electromagnetic wave perpendicularly at 90 degrees. So after projection it will hit the surface. So if you consider a unit area, so in that unit area how much energy was transporting, okay, through that unit area, how much energy was transporting per second, per 1 second, that is known as intensity of EM wave. So that one we have to calculate here, right? So EM wave have both electric and magnetic field. Correct, EM wave is due to both electric and magnetic field. So how much intensity was traveling through it, right, through 1 unit area, right? Let us calculate that. So what is the question? Intensity of electromagnetic wave. So electromagnetic wave, what is intensity? The energy of EM wave transporting, okay, transporting through unit surface area or unit area per second. This was the intensity of the EM wave. So EM wave is due to both electric and magnetic fields, right? So let us consider a surface, consider surface which has area A. Okay, so we are considering the area A, and now with speed v, the electromagnetic wave was hitting the surface. So speed of EM wave was is equal to v. Okay, now it was hitting perpendicularly, no? So I can it contains E, B. E means electric field, B means magnetic field. So I consider a surface. Now the electromagnetic wave is hitting perpendicularly. Okay, this is hitting perpendicularly at what angle? 90 degrees. This was the 90 degrees it hitting with it contains electric field, magnetic field, and with velocity v, right? So it was hitting perpendicularly. So light falling on, this was surface A. Consider surface A. Okay, this surface on surface A at perpendicular, surface A perpendicularly. Now I want to calculate the intensity. Let us now what I have to do, see, there is a energy density, it has some energy density due to both electric and magnetic field. Okay, so energy density due to electric field was energy density due to electric field. electric field. What UE is equal to energy density due to magnetic field. Okay, for both it will have like energy density, magnetic field UB. So what is the energy density here due to electric field? Half epsilon naught E square. So it is the energy density due to electric field. What is the energy density due to magnetic field? 1 by 2 mu naught B square. Okay, half epsilon E square is this one, like 1 by 2 mu naught B square. Right. Now total energy density. Total energy density. So what is the total energy density? U is equal to UE plus UB. What is UE? Half epsilon naught E square plus what is due to magnetic field? 1 by 2 mu naught B square. Correct. And here you can know, B is equal to, since B is equal to E by V. Okay, magnetic field is equal to electric field by velocity. So like you can substitute E, like B is equal to E by V, right? Half epsilon naught E square plus 1 by 2 mu naught E by V whole square, right? So half epsilon naught E square plus 1 by 2 mu naught E square by V square. Correct. You know, like in previous case, like while calculating the in vacuum, you came across like velocity is equal to 1 by root mu naught epsilon naught. Then what is 1 by V square? Here 1 by V square, no, it was like mu naught epsilon naught. Correct. Like 1 by V is root over mu naught epsilon naught, 1 by V square is mu naught epsilon naught. So I will substitute here half epsilon naught E square plus 1 by 2 mu naught, 1 by 2 mu naught, 1 by V square is mu naught epsilon naught E square, right? So this mu naught gets cancelled, mu naught gets cancelled. Then what I will get finally? U is equal to half epsilon naught E square plus, and again mu naught get cancelled now, so half epsilon naught E square, half epsilon naught E square, half epsilon naught E square. Okay, so half epsilon naught E square, half, like total how much? 2 into half epsilon naught E square. Okay, this is the like energy density, total energy density. Now I want average energy density. Average energy density. So average energy density means like this one is equal to U by 2. Okay, U by 2. So what is U here? You got 2 into half epsilon naught E square by 2, right? So 2 gets cancelled. Finally I will get half epsilon naught E square. This was average energy density. Correct. Now this is the average energy density. Again I want like energy transporting, like energy transporting through the area A. Okay, energy transporting through volume V R, right? So I want the value energy transporting through volume V. So you know, like see, right? So you know the intensity. So what I want? Energy, like average energy. Okay, this was like average density. Okay, energy density, this was energy density, that was average energy. So average energy transporting, what is the average energy transporting? E by volume. So E by volume, like general formula, E by volume is equal to average energy density. Now I want average energy transport now, so average energy transport is equal to average energy density into volume, right? Correct. Now average energy is equal to what is the average energy density? Half epsilon naught E square, half epsilon naught E square into volume. Volume is it was transporting through like a certain volume. Now what is the volume? Area into length, like total area into length, right? Volume formula that all know, like area into length, area into length. Okay, so this was the average energy, right? Now what I want, energy transporting per unit area. Okay, and what is intensity? Energy transporting per unit area per second. So I want like per unit area, so I will transfer this area to left hand side. Okay, so I will transfer this area to left hand side. Then what I will get? Average energy transport per unit area, no? So average energy transport per area is equal to half epsilon naught E square into length. And what is intensity? Average energy transport per unit area per second. So I have to divide with time also. Okay, so average energy transport per area into time is equal to half epsilon naught E square into length by time. Okay, so average energy transport per area per unit time, which is known as like intensity. Intensity is equal to half epsilon naught E square. This was length by time, like distance by time. What? Speed. Speed is equal to distance by time. Distance is speed in time. Speed is equal to distance by time. So speed. Okay, so what is the speed? We took like the initially at with what speed it was like incident on that surface v. Okay, so intensity is equal to half epsilon naught E square v, right? This was the intensity. This was the intensity of electromagnetic wave. Like epsilon naught, permittivity. E, like electric field. At what with what electric value it was projecting. Velocity, speed of the electromagnetic wave. So you will get the intensity. Yeah, this was the intensity of EM wave. Correct? Yeah. Thank you.